You know, when you think about surviving in space, you often think of um, some kind of sci-fi energy shield, right?
Right. Something protect you from all the dangers out there.
Exactly. Well, it turns out our planet has one, and finding one on another world has been a huge challenge.
Until now.
Today, we're doing a deep dive into how scientists finally found evidence of an invisible magnetic shield on a rocky world 12 light-years away, a planet called YZ Ceti b.
And it's a truly remarkable story of detection. YZ Ceti b is, well, it's an extreme case.
How so?
It's a terrestrial world, a bit smaller than Earth, orbiting a red dwarf star. But it's orbiting so close, it completes a full year in just 2 Earth days.
2 days. That's incredibly fast.
And that speed, that really close, rapid orbit, is actually the only reason we could even make this discovery.
Okay, so let's get into that, the discovery. They used the Carl Jansky Very Large Array, the VLA.
Yep, a massive radio observatory.
And the signal they found wasn't just noise. It was these repeating bursts of strongly polarized radio light.
That's the key phrase right there. Strongly polarized.
What does that tell us? What does that actually mean?
Well, it's basically the smoking gun for a magnetic field. When we say the light is polarized, it means the radio waves are all spinning in one predictable direction. And, that kind of organized spin is a telltale signature of a very powerful magnetic field directing traffic, so to speak.
And the other clue wasn't just what the signal looked like, it was the timing, right?
Exactly. The timing was perfect. These bursts were lining up almost perfectly with the planet's 2-day orbital period.
So that points directly to some kind of interaction between the star and the planet.
It does. It points to a model we call star-planet interaction, or SPI. Think of the planet YZ Ceti b like a massive conductor.
Okay.
And it's just plowing through the star's own magnetic field at incredible speed. It acts like a giant electric engine.
A sort of cosmic dynamo?
A cosmic dynamo. That's a great way to put it. This motion generates a colossal electric current.
So is the planet causing like a short circuit on the star?
In a way, yes. That current travels back along the star's magnetic field lines and slams into the star's atmosphere.
And that creates an aurora.
A very, very intense aurora on the star itself. We aren't detecting the planet's shield directly. We're detecting the star's reaction.
And seeing that periodic flare-up on the star confirms the planet must have its own magnetic field to drive the whole process.
That's it. That's the discovery.
But that raises a pretty big question for me. If this whole mechanism relies on a planet orbiting super fast and super close, a world that's way too hot for life,
Right.
does that mean we can only use this technique on the most extreme, uninhabitable worlds? Does it sort of limit us?
That's a great point and a real challenge. YZ Ceti b was the perfect test because the effect was so strong, it was almost impossible to miss.
So it's a good place to start.
The perfect
Yes.
place. But what it does is it proves we can detect the magnetic life of small rocky planets. That is a huge step forward.
Because before, we could only do this for what? Gas giants?
Exactly. We could see it with massive planets like Jupiter and its moon Io. But this is the first time for a terrestrial world. It's a new tool in the toolbox.
And I have to imagine the modeling for this was intense. You're trying to pull a tiny, repeating signal out of all the natural chaos of a star.
Oh, it truly was. Separating the star's own radioactivity from the planet's signal requires some serious computational power.
This deep dive is sponsored by Silk. If that sheer complexity of astronomical modeling has you thinking about AI and computation, you should check out Silk. Need help with AI training, automation, or even software development? Silk is all about uncovering where AI agents can make the biggest impact for your business or your personal life. Check them out at embersilk.com. So back to the science. Let's talk about why this magnetic armor is so critical in the first place.
Well, for these planets orbiting active red dwarfs, the star is just constantly blasting them with stellar wind and huge flares.
A really hostile environment.
Extremely. Without that magnetic shield, the atmosphere just gets stripped away, gone. And with it, any chance for life to get a foothold.
So this technique, this new radio method, is really about filtering, isn't it?
That's the real optimistic takeaway here. It's a revolutionary filter. We can now prioritize our search for biosignatures.
So we won't waste time on worlds that look good on the surface, in the right zone, but don't have that fundamental protection.
Exactly. We're moving from just finding planets to actually assessing if they could survive long term.
So when you boil it all down, the analysis of YZ Ceti b, it transforms this key ingredient for habitability.
The magnetic field.
From just an idea, something we hoped was there,
Yeah.
into a measurable piece of hard data.
It's just an incredibly hopeful path forward. It really shows our own ingenuity, that we can figure out ways to reach across space and understand the very architecture of another world's survival.
If you enjoyed this deep dive, please subscribe to the show. Hey, maybe leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.